Here's a review of significant figures for anyone who wants to go through this. Of course, sig figs in physics are important, and there's more than one way to do significant figures. We're going to do what most professors would use so that you're prepared for next year, but be aware that not everybody does significant figures the exact same way. So you will have to check with your prof to see if they've got their own way of doing significant figures. Remember, there are only two rules to identifying the number of significant figures. Zeros before the number are never significant, and zeros at the end of the number are significant when there is a decimal. So our first example, 910.0. There are no zeros in front to worry about, but we have two zeros at the back. There is a decimal present, so that means those zeros are significant because zeros after a number are significant when there is a decimal present. So since they are significant, that will give us four significant figures. When we put into scientific notation, we have to have 4 digits in scientific notation because we said there are 4 significant figures. So that'd be 9.100 times 10 to the, well, the decimal moves 2 spots, so times 10 to the positive 2, and positive because 910 is a big number. $910. No zeros in front of the number to worry about, but we do have a zero at the end again. And that zero is not significant. It says zeros after a number are significant when there is a decimal present. Since there is no decimal, the zero at the end of the number is not significant. So I would underline it. I only have two significant figures. That's the 9 and the 1. So I would write 9.1 times 10 to the positive 2. Times 10 to the positive 2, positive because it's a large number, and 2 because the decimal typically would be located right about here, and it had to move 2 spots to get behind the 9. Zeros before a number are never significant, so that means these zeros are not significant. Second rule we don't have to worry about because there are no zeros at the back of the number. So since zeros at the front are not significant, I underline the zeros at the front of the number. That means I only have two significant figures. So I'll write those two significant figures in scientific notation. That'll be 9 and 1. 9.1 times 10 to the negative 2 because the decimal had to move 2 spots to get behind the 9. And negative because 0.091 is a small number. Small numbers get negative exponents. Next example, 9,100. Zeros before a number are never significant. We don't have to worry about that. There are no zeros in front of the number. I have zeros at the end of the number though. Are they significant? Well, zeros after a number are significant when there is a decimal present. We have a decimal here, so that means that the zeros are significant. So that gives me four significant figures, 9100. So in scientific notation, that would be 9.100 times 10 to the positive 3. Positive because it's a large number, 3 because the decimal had to move 3 spots to get behind the 9. Zeros before a number are never significant, so that means these zeros are not significant because they are before the number. Zeros after a number are significant when there is a decimal present. These zeros are after the number. There is a decimal present, so that means the zeros at the end are significant, but the zeros in the front are not. So that means I have four significant figures, 9100. So I'll write that in scientific notation. And that gives me 9.100 times 10 to the negative 3. 9.10. First rule, we don't have to worry about it because we don't have any zeros in front of the number, but we do have a zero at the end. And zeros after a number are significant when there is a decimal present. We have a decimal, so it is significant. So we have three significant figures. 9, 1, and 0 are all significant, so they go into scientific notation. And then I wrote times 10 to the 0 because the decimal did not move. In fact, since the decimal did not move, when it says scientific notation, I don't have to write times 10 to the anything, so I would prefer if you wrote 9.10. If you had written times 10 to the 0 after the 9.10, that's okay, but it's not necessary. What is the significant figure rule when multiplying and dividing? Well, if we remember, we take a look at the numbers being multiplied or the numbers being divided, and whichever has the fewest number of sig figs, that is how many significant figures will be in my answer. So in our second set of examples, I've got 9.40 meters per second multiplied by 0.21 seconds. The first number has 3 significant figures. The second number has 2 significant figures. When I run it through my calculator, it says the answer is equal to 1.974. 2 is smaller than 3, so that means my answer is allowed to have 2 significant figures. So that means 1.9 will be my significant figures, and I will round off the 7.4. The 7 is the closest number to what we are dropping, and the rule is if it is a 5 or larger, it will bump the number up. So 1.9 becomes then 2.0. Now I have a unit of meters. How did I get my unit of meters? As mentioned in class, I like it when we write them as 2 fractions. So I have meters per second multiplied by seconds over 1. I can see I have an S on the top and an S on the bottom. They will factor out. And that will leave me with an M on the top and a 1 on the bottom. And M divided by 1 is equal to just M. In example B, I've got 310 meters per second. 310, there is no decimal, so that means that number only has 2 significant figures. It is being divided by 2.100. Both those zeros are significant at the end of the number because there is a decimal. So 2.100 has 4 significant figures. When I ran through my calculator said the answer is 147.619. I have 2 sig figs and 4 sig figs. 2 is smaller than 4, so my answer again is only allowed to have 2 significant figures. So I will keep the 1 and the 4. The 7.619 will be rounded off. So the 1.4 will become 1.5. So 147 then becomes 150 meters per second squared, which could also have been written as 1.5 times 10 to the 2 meters per second squared. Now, where did I get my unit from? Again, I want to write both units as fractions. I have meters per second divided by seconds, which is written as seconds over 1. Remember back in math class years ago, you were told when you have 2 fractions and a division sign, you will want to switch that division sign to a multiplication sign by taking the reciprocal of the second fraction. So I wind up with meters per second multiplied by 1 over seconds. Now I can merge the 2 fractions. I do not have anything that will factor out. I wind up with an M on the top and 2 S's on the bottom. An M on the top gives me just M on the top, 2 S's on the bottom give me S squared on the bottom. What is the significant figure rule when adding or subtracting? We said we like to put our numbers into columns. We draw a round off line when one of the numbers being added or subtracted, whichever one first runs out of significant figures, and then we keep what's in front of the round off line and we round off what's behind. So these are the 2 examples we're going to do. We want to line them up so that the ones are over the ones, decimals are over the decimals, tenths are over the tenths. So when we line them up in columns, this is what it would look like. If I look at the first example, I have 24.3, which runs out right here. I've got 75.5, which runs out right here. So I'm going to draw my round off line. They're both in the same spot. So my round off line will run down here. Whoop, there we go. And we are keeping everything that's in front, which is 100.0. So I would write 100.0. And then meters plus meters gives me meters because adding and subtracting does not change our unit. So that would be our answer. Or else we could write it as 1.000 times 10 to the 2 meters. In the second example, I only have two significant figures in the first number because that 0 is not significant. In the second number, I have two significant figures as well, but that runs out after the 3. So as I go left to right, the top number runs out of significant figures first, right through here. So 210 subtract 93, that gives me two significant figures because that's what's in front of the round off line. We're dropping the 7, we have 1 in front. So that becomes then 120, or 1.20 times 10 to the 2. And our units are kilograms. And that's it. Last thing we're going to do are BEDMAS calculations. You need to keep track of your significant figures as you work through the question, and only round once you get to your final answer. My notation I use that when something is not significant, I underline it so I know which of the numbers I've written are significant and which ones are not. A little note here, if you get to an adding or subtracting step and the units are not identical between the two numbers, you've made a mistake somewhere in your calculation. So the first thing I'm going to do is, I'm going to do some addition here because it's in brackets. I also have the subtraction that's in brackets. And since it's addition and subtraction, they have to go into columns. So when I do the addition, the top number has three significant figures. The top number running out of significant figures after the 4. The bottom number has 5 significant figures running out after the 2. As I go from left to right, it is the bottom number that ran out of significant figures first. So my round off line is drawn right through here. And I rewrite that number up here, 21.335, and I underline the 4 because the 4 is not significant. Then I did the subtraction as well. I had 5.230, which ran out of sig figs right here. 0.034 ran out of sig figs at the exact same spot. So when I drew my round off line, it runs right through here, which means everything is significant. So I rewrote the number up here with nothing underlined because all those numbers are significant. I then carried out the division. I had 5 significant figures divided by 4 significant figures. 4 is smaller than 5, so my answer has 4 significant figures. I'm dropping the 1 and the 2, so 4.106 remains 4.106. If I look at my units, liters plus liters gives me liters. Liters subtract liters gave me liters. And then I had liters divided by liters, which then left me with no unit. Example 2. I'm going to start by dealing with what I have inside the brackets. It's subtraction, so I have to put it into columns. Top number has 4 significant figures running out after the 0. Bottom number has 4 significant figures running out after the 8. As I go from left to right, it's the top number that runs out of significant figures first. So when I drew my round off line, the 987 is significant, but the 2 is not, so I underlined it when I substituted it back into my equation. Now I'm going to have to square what's inside of brackets here. And that's just multiplication. 3 sig figs multiplied by 3 sig figs gives me 3 significant figures. My calculator says 9,745.6384. and I'm going to underline everything except for the first three numbers that can be significant figures. So I know that only has 3 sig figs. Now I'm going to multiply 9,745.6384. I put it all in my calculator. I'm going to multiply that by 45.45. 3 sig figs, 4 sig figs. My answer then has 3 sig figs. So I'll punch it in my calculator, write down the whole number, and I will underline the 939.2653 so that it shows that I only have 3 significant figures in that number. Now I'm going to do division. I have 3 sig figs divided by 5 sig figs. I punch in my calculator, I write the number down. 3 is smaller than 5, so my answer is only allowed to have 3 sig figs. So I'm going to underline the 45.27167. And when I drop that, 188 remains 188. So that will be 1.88 times 10 to the 4 because the decimal moved 1, 2, 3, 4 spots to get behind the 1. Now to look at the unit, I started off with subtraction, meters per second. Subtract meters per second gives me meters per second. I then squared that. The square gets applied to everything inside the bracket, so m becomes m squared. S becomes s squared. I'm going to multiply that by seconds now. That's an S being placed on the top. There are 2 S's on the bottom, so that leaves 1 S on the bottom. And the 2 M's that were on the top remain on the top. Now I'm going to divide by M. That's putting an M on the bottom. I've got 2 M's on the top, 1 on the bottom. They're going to factor out. This M will take out one of these M's, leaving 1 M on the top. And then that 1 S that was on the bottom will get carried down, and I will wind up with meters per second. Of course, you probably want to write it out step by step on the side of your paper as you go. Now for our final example, I'm going to start off with what's inside of brackets, and that is subtraction, so I'll line it up in columns. The top number runs out of significant figures after the 0. The bottom number runs out of significant figures after the 2. As I go from left to right, it's the top number that runs out of significant figures first, so I will underline the 2 because it is not significant, and I will substitute that number back into the equation. Now I'm going to have to do the squared. Again, that is 4 significant figures multiplied by 4 significant figures, because that's what a squaring is. So I will punch that into my calculator, and I will keep 4 significant figures. So the 160.0 drops down, the 0.050 drops down, but this number we squared gets replaced with 392.515344, and I underlined the 15344 so that that number would only have 4 significant figures. Now I'm going to have to do division first before I do the multiplication that's here or here, because I have to strictly follow the rules of BEDMAS, and it says division does come before multiplication. So the 160.0 drops down, the 112.310 drops down, but this division step, I've got 2 sig figs multiplied by 4 sig figs, so I'll punch that into my calculator. This is what it spits out, and I'm going to underline the 7383 because it is not significant, but the 12 is because those are 2 significant figures. Remembering, zeros in front cannot be significant. So this number now has 2 significant figures. Now I'm going to multiply 4 sig figs multiplied by 2 sig figs. This is what my calculator says. The 2, 0 will be my significant figures. I will underline 381368 because they are not significant. I'm doing multiplication again. 2 significant figures multiplied by 5 significant figures means my answer is only allowed to have 2 significant figures, so that's 0.25. I'm dropping 0.89465. So 0.25, since I'm dropping a 0, that's the nearest. That will give me 2.5 times 10 to the negative 1 seconds, or 0.25 seconds. To run through the unit quickly, I've got meters per second, subtract meters per second, which gave me meters per second. The next thing I did was square, so that gets distributed into the brackets. So m becomes m squared, s becomes s squared. Next thing I did was division. Meters per second divided by meters squared per second squared. So if I were to write that out, that would be meters per second divided by meters squared per second squared. I would change that then to meters per second times second squared over meters squared. Meters factor out with one of the meters. Seconds will factor out one of the seconds, leaving me with seconds over meters. Now from there, I was just doing straight multiplication. I had meters times seconds over meters, which gave me then just seconds. And then I was multiplying by something that didn't have a unit at all, and that's how I wound up with just seconds in the end. And that's it. You're good to work on the physics skills 1.